Hello everyone, welcome back to RareCam Official. This video is about ionization energy. If you like this video, please like, share and subscribe. Without delay, let's get started. Ionization energy is the minimum amount of energy required to remove an electron from its valence shell in an isolated gaseous atom. What is isolated gaseous atom? In isolated atom means it is a single atom like lithium, sodium, potassium. Ionization energy is always measured in gaseous state because in solid and liquid states the electrons are in bonded state. If take a Cl2, these two chlorines are sharing a pair of electron by covalent bond. Higher energy of high energy is required to remove an electron from its higher energy of higher energy is required to remove these bonded electrons. So ionization energy is always measured in gaseous atom, isolated gaseous atom, because isolated means single. If take lithium, lithium atomic number is 3, configuration is 1s2 2s1. In first shell, uh, 2 electrons, in outer shell has 2 electrons. These 2 electrons are very close to the nucleus. This electron is mm, away from the nucleus, so very less amount of energy is required to remove this electron. It forms Li plus 1, Li plus ion. This is called first ionization energy. If remove second electron from its, see these two electrons are very close to the nucleus, or more attraction towards the nucleus, means higher amount of energy required to remove this electron. See, it forms Li plus 2 ion. So this is called second ionization energy. Second ionization energy is always greater than first ionization energy, because here, why second ionization energy is greater than first ionization energy means, here in neutral atom number of protons is 3, number of electrons 3. Here in first ionization energy, number of protons is 3, number of electrons 2. In coming to second ionization energy of lithium, here number of protons 3, number of electrons 1, because number of electrons is decreasing from neutral atom to second ionization energy of of lithium plus 2 ion, decreasing the electrons attraction between electron and proton increases, and second ionization energy of Li plus 2, or second energy of any atom increases. Then first ionization energy. uh, ionization energy in groups decreases in period, in across the period ionization energy increases. Why ionization energy decreases in groups, why ionization energy increases across the period? Let's look some factors affecting ionization energy and some exceptions in ionization energy. First, let's observe some factors affecting ionization energy. Atomic radius is inversely proportional to ionization energy. If atomic radius is increases from top to bottom, and it decreases from left to right. See, if you take from top to bottom, number of shells increases. If atomic radius is decreases from left to right. If take hydrogen atom, here in first in outermost orbital has one electron, because 1s1 configuration. See, this electron is whenever little smaller the size, electrons are very close or near to the nucleus, means whenever electrons are near to the nucleus means attraction is more. Whenever attraction is more, higher energy is required to remove an electron. So atomic radius is inversely proportional to ionization energy. So here, smaller the size, higher amount of energy is required, because electrons are closer to the nucleus or near to the nucleus. So in from top less from in across the period, ionization energy is increases. um, Shielding effect is inversely proportional to ionization energy. What is shielding effect? From top to bottom, number of cells increases. Here, if you observe, this cell is acts like a screen. These electrons in first shell electrons and outermost orbital electrons get repelled. Whenever get repelled, electron is easy to remove, or less energy is required to remove these electrons. Whenever less energy is required means from top to bottom, shielding effect is increases, ionization energy decreases. Nuclear charge is in directly proportional to ionization energy. If take ionization energy is more, nuclear charge is more, ionization energy is more. Penetration power of orbitals directly proportional to ionization energy. S orbital is greater than p orbital is greater than d orbital, and d is greater than f orbital. S orbitals is more penetration power than p. P also has more penetration power, but not that much like s orbitals. D and F has lower penetration effect. So low ionization energy is lower. Stable configuration is directly proportional to ionization energy. If take um, some examples: carbon, nitrogen, oxygen. um, Carbon atomic number is 6, 7, 8. Atomic number is 7 for nitrogen. See, actually what we discussed, carbon is from top in across the period, ionic radius is increases, right? But actual trend for oxygen has more ionization energy, but here um, nitrogen is a greater ionization energy than oxygen, because nitrogen is half filled. See, half filled. So whenever atoms has full filled or half filled, the ionization energy is more. So stable configuration is directly proportional to ionization energy. Let's look some exceptions. Suppose if you look beryllium and boron, if you observe beryllium and boron atomic number is 4, electron configuration is 1s2 2s2. For boron 1s2 2s2 2p1. See, actually boron has more ionization energy than beryllium, but here we observe beryllium has more, because electrons in beryllium in 2s, electrons in boron in 2p orbitals has also has present. In 2p orbitals has less penetrating power, and also p orbitals are much uh, little away from the nucleus. So beryllium has higher ionization energy than boron. uh, Same explanation for magnesium and aluminum also, but not electronic configuration. Here 1s2 2s2 2p6 3s2 for magnesium, because its atomic number is 12. Aluminum atomic number is 13, and its configuration is 1s2 2s2 2p6 3s2 3p1. If you observe nitrogen, nitrogen and oxygen, actually oxygen has more electron uh, ionization more ionization energy than nitrogen, because actual trend is atomic size is decreases, and ionization energy is increases from in across the period. But here factors affecting in ionization energy, we already discussed. Full filled orbitals or off filled orbitals are more stable and directly proportional to ionization energy. So nitrogen is off filled configuration, so it is directly proportional to ionization energy. That's why nitrogen is more ionization energy than oxygen. In comparing with the phosphorus and sulfur, these two uh, uh, atoms um, um, also three. Suppose phosphorus also has 3p3 configuration in outer configuration, so this is also half filled. That's why p is great phosphorus is greater than sulfur. Mm, so here we conclude that from top to bottom ionization energy is decreases in across the period, ionization is increases. That's all for today. Thank you for watching.